hate litter as much as we do? We're Keep America Beautiful, and we're challenging everyone in America to pick up 25 pieces of litter between now and Earth Day. Take the pledge and join the greatest American cleanup at kab.org/greatest.
Welcome to Do Beautiful Things. I'm your host, Jenny Lawson, President and CEO of Keep America Beautiful. In this podcast, we'll discuss ending litter, the truth behind recycling, and making communities beautiful for people and for a more sustainable future. We'll be talking to industry experts, community leaders, and everyday people who want to do the right thing, including from time to time, my mother. Thank you for joining us. I hope you learned something, and I know I will.
Welcome back to Do Beautiful Things, the podcast where we celebrate the power of small actions, big ideas, and bold innovations that make our world and beyond a cleaner, greener, and more beautiful place. Today, we're taking our mission to new heights, literally. At Keep America Beautiful, we believe in the power of education, inspiration, and action to drive positive environmental change. That's why we're so excited about today's topic, the LunaRecycle Challenge, a groundbreaking competition at NASA with a $3 million prize, pushing innovators to rethink recycling, not just here on Earth, but in the vast, uncharted environment of space. So how can the future of lunar recycling inspire us to rethink waste and improve recycling in our own backyards? Stick with us, because today's episode is packed with insight, inspiration, and of course, people doing beautiful things for the planet, on Earth, and in the galaxies beyond. We're thrilled to welcome Jennifer Edmunson, Acting Program Manager for NASA's Centennial Challenges. With a PhD in Earth and Planetary Sciences, she spent years advancing space sustainability, studying the Moon and Mars, leading resource utilization projects, and developing technologies for long-term exploration. From NASA's 3D printed habitat challenge to planetary surface construction, Jennifer is reimagining how we use resources in space. Today, she's here to share how the Lunar Recycling Challenge could revolutionize recycling, both on the moon and here on Earth. Welcome, Jennifer.
Hey, it's very nice to be here.
I am so excited to talk today and learn a little bit more about the Lunar Recycling Challenge. Tell me a little bit about the challenge. How does it work, and how does it fit into that larger Moon and Mars strategy?
So the LunaRecycle Challenge is a Centennial Challenge, and Centennial Challenges program is the flagship of challenge programs within the government. We tend to look for audacious and inspiring topics, and we tend to give prize purses that'll catch your eye, definitely. For the LunaRecycle Challenge, our target is trying to reuse and recycle as many materials as we can for space missions. So imagine that we take up a large amount of material to the moon, and we only have that amount of material to work with. We want to make sure we get the maximum value out of the material that we take with us. And since the material is already there, we call it an in situ resource. And we have to maximize the value to make human life on the moon sustainable. I mean, it's really the only material that we can have. We have to wait 3 days at least to get any cargo supply missions to the moon. So if there's an emergency or something, we need to be able to make, the widget or the cog in the system that we need, because sometimes 3 days is a very long time. And if you have issues with, say, your life support system, you're going to really need something to help fix that situation. Yeah. The LunaRecycle Challenge is really cool because it takes waste that we typically have on, say, the International Space Station, things like foam packaging, our cargo transfer bags, fabrics, different types of plastics, and even like the drink packages that have those multi-layers on it. A lot of these materials are really difficult to recycle in general. So that's why we're crowdsourcing ideas through the challenge to address this issue. We don't want a lot of waste on the lunar surface. We don't want a lunar landfill. We really don't want that. We want to be able to use every single piece of material that we take up there. And the LunaRecycle Challenge actually has what we're calling 2 tracks. One is a digital twin, and that means that people will make designs in like a CAD program and other various programs that allow us to kind of test whatever design they've made, putting it into a lunar environment scenario where we can say, will this hardware survive like the thermal swings that we see on the lunar surface? Will it survive in the vacuum of space, or do we need to keep it inside a habitat or some pressurized container for it to be able to operate? There's also 1/6 Earth's gravity on the lunar surface. So gravity definitely has a lot of play in the different types of materials that you can recycle and generate on the lunar surface.
Those are huge obstacles, right? To what's possible.
Mm-hmm.
It all sounds to me like the greatest closed loop challenge, right? It really is. How do you close the loop in an environment where rather than being a nice to have, it's essential to the survival of the rest of the components, which it probably should be for us as well. But this is a really interesting way to approach it, and it's really timely. I was actually having a conversation last week with one of our corporate partners who is implementing sort of a closed loop within their own system. So the same packaging plastic problem, they are now collecting those and using that material as the plastic input into their 3D modeling printers, right? So that if you're going to model solutions and you're going to have all those 3D printers in space, right? Like the inputs, the resources to print the 3D thing out are basically from those recycled materials, which I just thought, even in this instance, is just kind of a brilliant way to solve an internal problem. And this one is, your problem is at scale for sure.
That's right. Exactly. We're looking at materials that we can use for either new food packaging or just taking the materials that we have already and being able to recycle those. We do have the second track within phase 1 of LunaRecycle, which is our prototype track. This is where inventors can design hardware and tell us about it and give us data analyses on it. And this hardware eventually could be used in the future for recycling these materials at home or introducing this new recycling technology to recycle centers that already exist that be able to scale up this idea and be able to use it to recycle more materials and be able to turn these materials into useful things like 3D printer filament or even structural materials. We could use aluminum as a structural material. There's so many possibilities.
It's just so interesting. Do you have examples already how some of these innovations have changed waste management here on Earth?
So this challenge is actually the first of its kind, and we're so excited to see how we can revolutionize the terrestrial waste management through the innovative solutions that we get from our competitors.
So why a challenge? What makes competitions like this a powerful tool for innovation?
So NASA uses competitions and prizes as one way of helping maintain and advance America's leadership in technology and innovation. And one way the agency achieves this is through the Centennial Challenges program. We were actually established in 2003 in honor of the Wright brothers' first flight. That's why it's called Centennial. And we ran our first competition in 2005. And since then, Centennial Challenges has drawn out so many creative solutions from academia and citizen inventors and industry for technologies like lunar landers, fuel-efficient aircraft, astronaut gloves, 3D printing of large structures, and software to improve autonomy of humanoid robots. And Centennial Challenges consistently works to create new ways to engage the community to bridge NASA's biggest technology gaps.
Well, and human gaps too, right? Like NASA takes these ideas to space, but it sounds like even the products you just listed off, each of those things has real applicability back here on planet Earth. It's very, very interesting. I'm want to step outside and ask, how did you get involved? What made this an interesting project for you?
I was involved with the 3D printed habitat challenge when Centennial Challenges was running that one. I was actually on the rules committee and on the judging committee for it. My background is actually planetary science, and I study the material that's on the surfaces of the moon and Mars. And one of the things that was used in the 3D printed habitat challenge was Martian-like material that they combined with, say, cements from Earth or polymers and various things like that to make structural materials. And the competition was fabulous. It was hosted by Caterpillar in Peoria, Illinois. Had a wonderful time at that event. And that was one of the challenges I was involved with. I was also part of the Break the Ice Lunar Challenge as kind of a sounding board for some of the material they were using to simulate icy regolith. The competition there was just excavating this icy lunar soil, basically. And they came up with so many different ideas that we had not really seen in the in-situ resource utilization community within NASA before. It was absolutely fantastic. New technologies from just garage inventors. And I was chosen as the acting program manager for Centennial Challenges when unfortunately someone had to go on medical leave, so I took over for her. But given my history with Centennial Challenges, that's why they chose me for this job.
So did you always like science and math? I'm going to ask the STEM question.
I did. Actually, I decided pretty much what I wanted to do when I was 3 years old and I saw the first shuttle launch on TV. I just decided at that point I want to work for NASA. And I always would play in the mud as a kid. I would dig up little river rocks and they'd be the same color. I'm like, oh, these must fit together. So geology was definitely in my path. And I've always enjoyed looking at the stars and the planets. And I did want to pursue astronomy, astrophysics and those sorts of things when I got into college, but then I'm like, no, let's combine these two efforts together. So I went for planetary science and I haven't regretted it at all. And because I do planetary science work, I get tied into things like the in-situ resource utilization technology development, like if they're trying to extract oxygen from the lunar material or if they're trying to build structures out of that material. And a lot of the Centennial Challenges and the technology gaps that we have within the Space Technology Mission Directorate are tied to those problems. So I feel like this is where I'm meant to be.
That's amazing. And I think, it's National Women's Month, I believe, here in March, which is when we're recording. So thank you. I think girls in STEM and science, I was a math major, so super geeky. I think it's really, important contribution that women are making. I had one question about the difference in thinking about recycling. So back to our topic, between how it may play out on the moon versus how it may play out on Mars. Because there's got to be variability to different degrees yet again for what people need to think about in those two separate environments.
Oh, absolutely. Especially if you're trying to have a recycle system that isn't in some kind of environmentally controlled enclosure. The lunar surface has an extreme vacuum. There's no atmosphere really to speak of. The material on the surface is incredibly dusty. It likes to stick to things. It's electrostatically charged. And the thermal swings, because there is no atmosphere, are so extreme that you really have to protect equipment. There's the radiation environment as well, because it's not protected all the time by Earth's magnetic field. So there's all kinds of considerations when you're designing hardware for lunar surface. When we go to Mars, it's different in that the gravity is greater because it's 1/3 Earth's gravity instead of 1/6 like the moon. It also has a carbon dioxide rich atmosphere. And carbon dioxide is a really good source for carbon for polymer materials. So we could potentially take the atmosphere and scrub the carbon out of it, making polymers and breathable oxygen at the same time. The Martian material is also different. There's a lot of weathering processes, which basically means that the surface was interacted with water at some point. There's wind on Mars, so you get sand dunes, you get clays, you get different types of materials that you don't really see on the moon, even though they're similar in a lot of different ways. So I believe that we could take what we learned from LunaRecycle and definitely apply it to Mars. I actually think if we conquer the moon, it would be a lot easier when we finally get to Mars.
Incredibly interesting. Putting recycling back into the narrative for this Centennial Challenge, how did you all end up with recycling as the next big area that you want to pursue?
We know that we're going to have to live on other planetary surfaces sustainably. We are doing our best to be able to maximize the uses for the materials that we take up there. It's so expensive to launch things from Earth. It actually takes about $10,000 for about 2 pounds of material to be launched to the space station. And the latest estimate that I saw on one of the commercial lunar payload services websites was that it costs $1 million to $1.2 million to get those same 2 pounds to the moon. It's incredibly expensive. So we need to maximize the potential for the materials that we take as well and be able to use them in things like in-space manufacturing and surface construction so that we're able to make what we need while we're there on the planetary surface.
And on some level, not make some of the mistakes we've made here on Earth, right? So maintaining the environment that allows those things to be recycled at high rates and be the resource that is going to be demanded of anything that's taken up to space. It's incredibly interesting. So talking a little bit about the challenge, for folks who are listening who have a great idea, have something they may want to contribute, what's the timeline for the challenge? How do people get involved?
So the phase 1 of the challenge actually launched in September of 2024, and phase 1 submissions are due March 31st of this year. After that, we do plan to have a phase 2 of the challenge. We're writing the rules right now, and we're using our lessons learned from phase 1 and applying that to our phase 2 as well. I'm not sure exactly what the time frame is for a phase 2, but all will definitely be welcome. It's not going to be closed off to people that were unable to participate in phase 1. So we will definitely open it up again, and then we could definitely keep you posted on when the next phase of the challenge opens.
That's great. We're happy to stay involved as a communicator because it's just so cool. You know, I think final area for discussion this afternoon is, are there ways that a LunaRecycle inspired technology could improve recycling here on Earth? What are you all thinking in that space?
So ideally, a recycling solution born from LunaRecycle Challenge will increase the number of materials that can be recycled and bring recycling even closer to home. There could also be breakthroughs in how we recycle hard to break down materials like clothing and plastics and packing materials, or find innovative solutions to reuse them in our own communities. And in the LunaRecycle rules, the competitors are told the devices that they design could be scaled for a crew of 8 living on the surface for a year. And that means they should be designed to handle 4,200 kilograms or almost 9,300 pounds of solid waste within the 6 categories that we've identified. And that's the foam packaging, cargo transfer bags, fabric, food packaging, structural materials, and plastic packaging. And assuming that a crew of 8 is probably oversized for most families in the U.S., but the devices used to recycle the materials could be scaled appropriately to allow greater recycling capabilities in communities and individual homes.
So Jennifer, thank you. Like the ways that recycling in space can influence recycling here on Earth are exciting and promising. There are other pieces to this as well. The sort of charter for Moon to Mars. Tell me a little bit more about its other objectives beyond the sort of technical framework of recycling.
So NASA's Moon to Mars strategy identifies maintainability and reuse and responsible use as critical to achieving long-term sustainability and presence on other surfaces. We're also trying to preserve the integrity of the environment we're exploring And we want to prove at the same time that humans are able to be truly independent from Earth when they're living on other planetary surfaces. And the Moon to Mars strategy includes explicit operational goals to use commodities produced from planetary surfaces to reduce the mass required to be transported from Earth and to minimize the disturbance to the local environment and maximize the resources available to future explorers, which allows for the reuse and recycling of material transported from Earth during exploration. And it's extremely expensive to fly a payload from Earth and have it land safely on the moon. And we want to make sure that we can maximize the value of any material that we fly. And that's part of why we started the LunaRecycle Challenge. It focuses on the approach for recycling materials, packaging, fabrics, all different kinds of things. And a lot of these materials are difficult to recycle on Earth, and the challenge has the potential to highlight entirely novel approaches to recycling and processes that improve energy efficiency, processes that reduce unusable outputs and toxic emissions, and smaller scale solutions that could be deployed in communities in a more distributed way than recycling facilities are today. And each of the competitor submissions have the potential to influence and inspire better approaches and outcomes for terrestrial recycling in the future.
I love it. Thank you. Thank you. Jennifer, this has been a terrific conversation. We appreciate your expertise and your dedication to this incredibly interesting challenge. We can't wait to learn a little bit more about the winner.
I'm happy to be here. Thank you so much, and we'll keep you posted.
That's a wrap on today's Out of This World episode of Do Beautiful Things. A huge thank you to Jennifer Edmunson for sharing her insights on the LunaRecycle Challenge and the future of recycling, both in space and even here on Earth. So if you're feeling inspired, visit lunarecyclechallenge.ua.edu to learn more about the challenge and how innovation can shape a more sustainable future beyond our planet. And while we look to the stars, let's not forget about our own home. We hope you will join us for the greatest American cleanup and be a part of the movement to create a cleaner, greener future for generations to come. Take the pledge today to recycle, pick up litter, plant native species, and inspire your neighbors to do the same. Visit kab.org/greatest to join the greatest American cleanup today. Until next time, take care, stay informed, and let's keep doing beautiful things together. See you in the next episode.